problem 29 of Neetcode 150. Search a 2D matrix. You're given a m by n 2D integer array matrix and also a target. Each row is sorted in ascending order, and the first integer of each row is greater than the last integer of the previous row. So they're basically doing all the sorting for us, which is great. And we have to tell whether the target is within this 2D grid or if it is not. All right, so if our target is 10, well, you can see that 10 is here, right? So we will return false. But if they want us to return 35, well, 35 is not here. So we will return false. Okay. So how do we solve this? Do we just go through every single value and check if it is actually the target? Well, that will be that will give us a time complexity of big O of n times m. We can do something better, which is a time complexity of log. Whoop. Sorry. Which is log n plus log m, which can be rewritten. So we can rewrite this as log m times n. Okay. So this is the solution that they want us to figure out. And let's go ahead and try to solve this. So how do we do this? Well, basically, you know that the binary search has a time complexity of big O log n. So having big O log n, which is the length of the row, and m is basically the number of row. So we are gonna have to use a binary search through every single row to see if our target is within any of these, because we know basically that, for example, if our target is 9, we know that basically the target is going to be greater than -1, so it cannot be here. We know that it is greater than 5, so it cannot be here. So we know right away that we can just apply the binary search to this here, the last row. So we won't need to check all the single values in the other rows. So basically the check is that we're going to check if the value is greater than the last element of the middle. If it is greater, we're just going to place our top value. So let's call this a top. And let's call this a bottom. So if it is greater, we are just going to move our top here. If it is lower, we are going to move our bottom here. All right, so we're going to do a vertical binary search and then an horizontal one. So let's go ahead and code this. All right, so the first thing that we want to do is to create a top and also a bottom, where basically the top is a 0 and the bottom, it's going to be the length of the matrix. So it's going to give us the number of row that we have. I think there, yeah, matrix -1. All right, and now we are going to write our binary search. So basically, while the top is smaller or equal to the bottom, so while the top is smaller or equal to the bottom, right? We are going to create our middle value, and this is basically going to be equal to the top plus the bottom. And we want to round this towards a zero, so that's why we have an integer division here. And now we're going to do our first check. So basically, if the target is greater than the last element at the middle row, so like this. Okay, so what do we do in this case? Well, we're going to increment our top. Well, in fact, our top is going to become the middle plus 1, right? So this is exactly like a normal binary search. We're applying this for a vertical purpose, but it is still the binary search. The other possibility is what if our target is smaller than the first element in that middle row. So in this case, the bottom will be basically the middle minus 1. All right. Otherwise, we just found the correct row that the value is in. So we are going to break our while loop. It is possible that the value is just not inside any of these rows. So we have to take that into account and say basically if the condition, if we just get out of the while loop without breaking it, we're going to say basically return false. So if that condition does not hold true, so if not top smaller equal than bottom, we are going to return false. And after this, we can start our vertical or horizontal binary search because we now found the row that the value is likely in. So we are going to create our start in our hand, where the start is basically 0 and the n is the length of the matrix. Honestly, any array within the matrix, because they're all the same length. And this is going to be minus 1. And now we do our basically while the start is smaller or equal than the n. Okay, we are gonna have our mid values. Be careful not to write actually male, because that's the value we previously had. So the male is gonna be equal to the start plus the n, integer division of 2. And now there's a potential that the target or that the matrix basically at that middle row, at that middle index, if this is smaller than the target, well, it means that our value likely lies in the right half of the array. Okay, so in such a case, we will basically set the start to the middle plus 1. And there's another case where the matrix at the middle row, at the mid element, is actually greater than the target, meaning that our value likely lies on the left half of the array. So we will set the n to the middle minus 1. So we can really focus on that left half of the array. Otherwise, well, it means that we found a match. We actually found the target, so we're going to return true. And if we break out of that while loop without returning true, it must mean that the value is not there. So we are going to return false. So there you go. takes a while. Time limit exceeded. So let's go ahead and review our code. Um, so yeah, I should have used another term than middle and mid because um, I misused them. I used the middle for the horizontal binary search while the middle was a variable used in the vertical binary search. All right, there we go. So it was not super complicated if you master the binary search. It's basically two binary search consecutively. So I hope you learned from this video, and I hope to see you in the next one.